More than 600 meters beneath the surface of the Caribbean Sea, west of Cuba, sonar equipment detected something that appeared strangely out of place. The shapes were not scattered like ordinary debris. They seemed organized. Long lines crossed the seabed. Angular formations appeared beside large blocks. Repeating patterns suggested platforms, corridors, walls, or stepped structures hidden in darkness far below the reach of sunlight. The discovery began in 2001, when a research vessel operated by Advanced Digital Communications crossed the waters near western Cuba. The company was conducting a seabed survey for the Cuban government. The mission was not designed to search for Atlantis, a lost civilization, or an unknown chapter of human history. It was a technical operation involving sonar mapping of the deep seafloor. Inside the vessel, researchers watched data move across electronic screens. The sonar system sent sound waves downward through hundreds of meters of seawater. Those signals struck the seabed and returned to the ship, creating an acoustic image of the terrain below. Most of the survey revealed irregular geological surfaces. Then the screen displayed an unusual concentration of geometric forms. Paulina Zalitsky, a marine engineer associated with Advanced Digital Communications, examined the patterns with Paul Weinsweit, one of the company's founders. The formations covered a large area of the seabed. Reports described a zone extending across several square kilometers. Some shapes appeared rectangular. Others seemed circular or pyramidal. Certain lines met at angles that looked almost unnaturally precise. The sonar images did not show a complete city. They showed acoustic reflections that could be interpreted in different ways. Sonar can identify variations in shape, elevation, density, and surface texture, but it does not automatically reveal whether a formation was produced by human activity. A rectangular image on a sonar screen may represent a fractured rock face, a volcanic structure, an unusual sediment deposit, or something modified by people. Even so, the arrangement was striking enough to justify a closer investigation. A remotely operated vehicle was lowered into the Caribbean Sea. The machine descended through layers of increasingly dark water. Sunlight disappeared. Pressure increased. The surrounding environment became cold, silent, and almost completely black. At a depth greater than 600 meters, cameras approached the formations detected by sonar. The images appeared to show smooth stone surfaces, large blocks, and structures with regular edges. Some formations resembled broad platforms. Others seemed to rise from the seabed like walls, step terraces, roads, or pyramidal masses. Sediment covered portions of the stone. Marine organisms clung to exposed surfaces. The limited visibility made scale and orientation difficult to judge. The researchers remained cautious. Paulina Zalitsky publicly described the site as unusual, but she did not claim that the evidence had proven the existence of a lost city. Paul Weinsweit also emphasized the need for further investigation. The forms were intriguing, but sonar images and short underwater recordings could not replace controlled archaeological excavation. Geologists considered several natural explanations. One possibility involved basalt formations created by ancient volcanic activity. When magma cools, it can fracture into regular shapes. Basalt may form columns, blocks, terraces, or polygonal surfaces. From a distance, these natural patterns can resemble architecture. Volcanic intrusions can also produce long ridges and angular boundaries beneath sediment. Another explanation involved natural fracturing along geological joints. Rock layers may break along lines of weakness. If several fracture systems intersect, the resulting forms can include right angles, flat surfaces, and repeated geometric patterns. Erosion may then enlarge those fractures, creating shapes that appear artificial when observed through low-resolution sonar. Tectonic activity may also have altered the seabed. The Caribbean region contains complex fault systems, submerged ridges, volcanic structures, and areas affected by crustal movement. Blocks of rock can be lifted, tilted, fractured, or lowered over long periods. A formation that appears level today may have experienced significant geological change. Oceanographers also warn that acoustic imaging can create misleading impressions. Sonar shadows may exaggerate vertical surfaces. The angle of the signal can make irregular formations appear symmetrical. Sediment can hide natural boundaries while emphasizing others. Without multiple survey passes, detailed bathymetric mapping, sediment cores, rock samples, and direct excavation, interpretation remains uncertain. Archaeologists faced an even greater problem. To identify a human-built structure, researchers would need evidence of deliberate construction. They would search for shaped stones, repeated masonry techniques, artificial foundations, tools, ceramics, worked materials, organic remains, or sediment layers connected to human occupation. None of these had been documented through a controlled archaeological excavation at the Cuban site. The depth created another major difficulty. Global sea level during the last glacial maximum was approximately 120 meters lower than it is today. That difference exposed enormous coastal plains around the continents, but it does not explain a site now located more than 600 meters below the surface. If the Cuban formations were once above water, scientists would need to consider tectonic subsidence, fault movement, crustal deformation, changing sediment loads, and the geological history of the region. It would be inaccurate to assume that the area was dry land only 50,000 years ago simply because sea levels were lower during the Ice Age. The relationship between present depth and past elevation is much more complicated. A structure now 600 meters below the sea could not have been exposed by a global sea level decrease of only about 120 meters unless major local geological movement had also occurred. That question has never been resolved. Further expeditions were discussed, but deep water archaeology is expensive. A research vessel must carry specialized sonar systems, underwater vehicles, navigation equipment, geological sampling tools, and trained crews. Weather conditions can interrupt operations. Political agreements are required. Equipment may fail under extreme pressure. A single expedition can cost millions of dollars while producing only limited evidence. Financial problems, technical obstacles, and political complications prevented the kind of sustained investigation needed to reach a firm conclusion. No large-scale excavation has demonstrated that the formations were constructed by humans. No inscriptions, tools, pottery, foundations, or datable occupation layers have been recovered from a secure context. The site therefore remains suspended between geology and archaeology. To supporters of lost civilization theories, the sonar images resemble the remains of a monumental settlement. Some have compared the formations to pyramids, ceremonial platforms, roads, and urban complexes. More extreme interpretations have connected the site to Atlantis or to an advanced Ice Age civilization. These claims go far beyond the available evidence. To many geologists, the most likely explanation is natural rock shaped by volcanic processes, faulting, erosion, and fracturing. Yet without detailed sampling and excavation, even this interpretation cannot be demonstrated with complete certainty. The most responsible conclusion is also the least dramatic. Unusual geometric formations exist on the seabed near western Cuba. They were identified through sonar and observed by a remotely operated vehicle. Their appearance has inspired archaeological interpretations, but no conclusive evidence has shown that they are artificial. The mystery survives because the evidence is incomplete. Yet the formations raise a larger question that extends far beyond Cuba. Even if these particular structures are natural, vast regions of the modern seafloor were once dry land. Human beings lived during periods when global coastlines were radically different. Rivers flowed across plains now covered by seawater. Forests grew where fishing vessels travel today. Camps, villages, hunting grounds, burial places, and migration routes may still exist beneath marine sediment. The mystery beneath Cuba therefore leads to a more important investigation. When were the oceans lower? What landscapes disappeared as the Ice Age ended? And how much of early human history now lies beyond the modern shoreline? Approximately 20,000 years ago, Earth looked familiar from space, but its coastlines were profoundly different. Vast ice sheets covered northern North America, Greenland, Scandinavia, and large regions of northern Europe. Mountain glaciers extended across areas that are now temperate. An enormous volume of the planet's water was trapped on land as ice. This period is known as the Last Glacial Maximum. Global temperatures were lower than today. Habitats shifted toward the equator. Deserts expanded in some regions while grasslands replaced forests in others. Animals and human populations adapted to cold environments, changing coastlines, and unstable climates. Because so much water was stored in continental ice sheets, global sea level stood approximately 120 meters below its present position. The exact level varied through time and from region to region, but the overall effect was enormous. As the ocean receded, continental shelves emerged as dry land. Modern maps hide these lost territories because coastlines are drawn according to present sea level. When the oceans are lowered on a paleogeographic reconstruction, the familiar outline of the continents begins to transform. Islands connect to mainlands. Gulfs become valleys. Shallow seas disappear. Broad plains emerge around river systems and continental margins. Britain becomes connected to continental Europe. The North Sea retreats, revealing a wide lowland crossed by rivers, lakes, marshes, and forests. Human groups can travel on foot between areas that are now separated by deep channels and busy shipping routes. Farther south, the Persian Gulf nearly disappears. In its place lies a broad basin containing river valleys and wetlands. The Tigris, Euphrates, Karun, and other river systems flow across a landscape that is now underwater. This region may have offered freshwater, fish, fertile soils, and protected habitats to prehistoric communities. Australia and Papua New Guinea become parts of a larger landmass known as Sahul. Lower sea levels expose the shallow seabed between them. People can move across landscapes that are now separated by the Arafura Sea and Torres Strait, although deep water crossings were still required to reach Sahul from Southeast Asia. In the Caribbean, lower sea levels enlarge islands and expose coastal shelves. Areas around Cuba, the Bahamas, and the Yucatan Peninsula extend farther into what is now the sea. River mouths shift outward. Coastal plains widen. Shallow channels become wetlands or dry corridors. These changes matter because human beings repeatedly concentrated near water. Rivers offered drinking water, fish, shellfish, transportation routes, fertile floodplains, and access to migrating animals. Estuaries supported rich ecosystems. Coastal lagoons provided protected fishing grounds. Deltas created environments where freshwater and marine resources could be collected within a small area. For prehistoric communities, these locations were not marginal. They were among the most valuable landscapes on Earth. Archaeological sites found on modern land may therefore represent only the inland portion of ancient human activity. The old coastal zones, where people may have lived in large numbers, are now submerged. The remains of their settlements may lie beneath sand, mud, coral growth, or thick layers of marine sediment. The rise of the sea after the last glacial maximum was not a single event. As the climate warmed, continental ice sheets began to melt. Water returned to the oceans over thousands of years. Coastlines moved inland gradually, but the process was not perfectly uniform. Some periods experienced relatively slow change. Other intervals saw more rapid increases associated with major releases of meltwater. For generations, a coastal community might have observed the shoreline moving only a small distance each year. Yet over centuries, the cumulative change could destroy hunting grounds, contaminate freshwater sources, flood river valleys, and force entire populations to relocate. A settlement built beside an estuary could eventually become surrounded by marshes. Later, waves might reach its foundations. Decades or centuries after abandonment, the entire site could disappear beneath the sea. This was coastal flooding caused by sea level rise, not a global wall of water covering every mountain. The process unfolded differently across regions. Local conditions depended on the shape of the land, the speed of sea level change, sediment accumulation, storms, tectonic movement, and the weight of melting ice. The land itself also moved. During the Ice Age, enormous ice sheets pressed down on Earth's crust. When the ice melted, previously compressed regions began to rise through a process known as glacial isostatic adjustment. Other areas, located beyond the former ice sheets, could sink in response. As a result, relative sea level change varied significantly from one coastline to another. Some ancient shores are now deep underwater. Others have risen above modern sea level. A single global estimate cannot explain every local archaeological site. This complexity is especially important when evaluating claims about lost civilizations. A submerged formation cannot be dated simply by measuring its depth. Researchers must reconstruct local tectonic history, past sea levels, sediment movement, erosion, and crustal deformation. Even so, one fact is not disputed. Millions of square kilometers of land occupied during the Ice Age are now underwater. These exposed continental shelves were not empty. Human beings had already spread across Africa, Europe, Asia, Australia, and the Americas by the end of the Pleistocene. They hunted, gathered plants, fished, created tools, used fire, built shelters, buried their dead, produced symbolic art, and transmitted detailed knowledge across generations. Some communities were highly mobile. Others returned repeatedly to productive rivers, lakes, and coasts. Seasonal camps may have developed into more permanent occupation zones. Social networks connected distant groups through exchange, marriage, migration, and shared ritual practices. Most of this activity left fragile traces. Stone tools may survive. Bone may survive under favorable conditions. Wood, fiber, leather, food remains, woven materials, and shelters usually decay. Underwater environments may preserve some organic materials exceptionally well, but currents, waves, oxygen, microorganisms, and sediment movement can also destroy evidence. The archaeological record is therefore incomplete even on land. Beneath the sea, the missing record becomes far greater. Modern researchers use bathymetric mapping to identify ancient valleys, channels, terraces, and coastlines. Seismic survey data can reveal buried landscapes beneath sediment. Sediment cores preserve pollen, microscopic organisms, chemical signatures, and evidence of environmental change. Underwater vehicles can photograph surfaces beyond the reach of divers. These technologies are beginning to reconstruct the world before the oceans reached their modern level. The emerging picture does not prove that an advanced global civilization existed during the Ice Age. It does not reveal lost machines, universal writing systems, or monumental cities beneath every continental shelf. What it does prove is that human beings occupied landscapes that have vanished from modern maps. The difference is crucial. A submerged stone tool demonstrates human presence. A concentration of tools may suggest a campsite or repeated occupation. Post holes, hearths, food remains, and constructed surfaces may indicate a settlement. Roads, public buildings, storage systems, administrative records, specialized production, and dense architecture would be needed to establish an urban civilization. Each category requires different evidence. The temptation to move directly from a submerged object to a lost empire can obscure the real significance of underwater archaeology. Even a small fishing camp may transform understanding of prehistoric migration, diet, technology, and social organization. The strongest evidence comes from landscapes where geology and archaeology can be studied together. One such landscape lies beneath the North Sea. For thousands of years, the region between Britain and continental Europe was not an ocean. It was a broad territory of rivers, wetlands, forests, and open plains. Animals crossed it. Human communities lived within it. Its existence has been confirmed through seismic mapping, environmental reconstruction, and archaeological finds. That drowned world is known as Doggerland. The modern North Sea is a cold marine environment crossed by cargo ships, fishing vessels, pipelines, and offshore platforms. Beneath its waves lies a landscape that once connected Britain to continental Europe. This landscape was Doggerland. During the final stages of the Ice Age, Doggerland extended across large areas now covered by the North Sea. Its precise boundaries changed as glaciers melted and sea levels rose. At different periods, it included broad plains, river valleys, wetlands, lakes, dunes, forests, and coastal lagoons. It was not a single political territory. The name is a modern geographical term used to describe a submerged prehistoric landscape. Paleogeographic reconstructions show major rivers crossing the region. Some channels carried water from areas that later became Britain. Others connected with drainage systems from continental Europe. Freshwater lakes occupied depressions. Marshes supported birds, fish, reeds, and edible plants. Woodlands expanded as the climate warmed. The environment attracted large animals. Mammoths crossed open areas during colder phases. Aurochs moved through grasslands and forest margins. Giant elk occupied suitable habitats. Red deer, wild boar, horses, and smaller mammals followed changing vegetation. Rivers contained fish. Coastal zones supplied shellfish and marine resources. Human communities also occupied Doggerland. Adult hunters moved along riverbanks in search of animals. Fishing groups used shallow waters and wetlands. People gathered plants, collected shellfish, shaped stone tools, worked antler, and built temporary shelters from wood, hide, and plant material. Much of this world left no visible ruins. The shelters decayed. Footpaths disappeared. Wooden tools broke down. Campsites were covered by sediment. As the North Sea expanded, the old landscape vanished beneath water. Yet evidence continued to return to the surface. Fishing crews operating in the North Sea occasionally pulled unexpected objects from their nets. Mammoth bones appeared beside modern fish. Antlers, animal teeth, and fragments of prehistoric fauna were recovered from the seabed. Stone tools and worked antler demonstrated that human beings had used the region before it was flooded. Some objects were discovered without secure archaeological context because fishing nets disturbed the seabed. Their original locations could not always be reconstructed. Even so, the repeated recovery of prehistoric material confirmed that the North Sea had once contained habitable land. Researchers then began using industrial geological data to map the drowned terrain. Companies searching for oil, gas, and suitable construction areas had collected enormous quantities of seismic survey data. Sound waves penetrated the seabed and reflected from buried geological layers. These records were originally created for commercial purposes, but archaeologists and geographers recognized their value. Researchers associated with the University of Bradford and other institutions used seismic information to reconstruct ancient rivers, valleys, lakes, estuaries, and shorelines beneath the North Sea. The modern seafloor became transparent in digital models. Buried channels appeared under layers of marine sediment. Former lakes were identified. Ridges and lowlands emerged. Researchers could estimate which regions would have contained fresh water, protected campsites, migration routes, and productive ecosystems. Doggerland was no longer an abstract land bridge. It became a complex environment with changing habitats. As the climate warmed after the last glacial maximum, the sea advanced gradually. At first, low coastal areas became marshes. River valleys widened into estuaries. Salt water entered freshwater systems. Productive land shrank. Communities moved toward higher ground or adapted to new coastal conditions. The flooding occurred across many generations. People living in Doggerland may not have understood that they were witnessing a global transformation. They would have experienced local changes, a familiar island disappearing during storms, a freshwater spring becoming salty, a hunting trail turning into a tidal channel, or a burial place being eroded by waves. Knowledge of the landscape may have been preserved through oral tradition. Adults could describe places that younger generations had never seen. Routes once traveled on foot might become accessible only by boat. A region remembered as a forest could become a shallow bay. By approximately 8,000 years ago, much of Doggerland had been submerged. Some higher areas remained as islands and peninsulas. Human groups continued to occupy surviving land where resources were available. Then a massive geological event occurred off the coast of Norway. The Storegga Slide was one of the largest known submarine landslides in the prehistoric North Atlantic. An enormous volume of sediment collapsed along the continental margin. The displacement of water generated a tsunami that traveled across the Norwegian Sea and into the North Sea. Geological evidence of the tsunami has been identified in coastal deposits. Layers of sand and marine material were carried inland and left above normal tidal zones. These deposits allow researchers to estimate the height and reach of the waves in different regions. A reconstruction shows the tsunami moving toward low coastal plains. Water enters river valleys and estuaries. Waves cross wetlands and strike exposed islands. Camps near the shore are destroyed. Freshwater habitats are contaminated with salt. Boats, shelters, tools, and food stores are carried away. The exact human consequences remain uncertain. The tsunami may have caused severe destruction in surviving parts of Doggerland. Some researchers have suggested that it accelerated the abandonment of low areas. Others emphasize that much of the territory had already been lost through gradual sea level rise before the Storegga Slide occurred. It would be misleading to claim that all of Doggerland disappeared in a single day. The region was transformed by thousands of years of coastal change. The tsunami was a sudden disaster within that longer process. It may have destroyed communities and made already vulnerable landscapes difficult to inhabit, but the scale of population loss is still being studied. Doggerland therefore provides two different models of catastrophe. The first is slow and generational. Sea level rises. Coastlines retreat. Families relocate. Habitats shift. Cultural knowledge adapts to a changing map. The second is sudden. A submarine landslide creates a tsunami. In a matter of hours, coastal settlements may be overwhelmed. Both forms of change could influence memory. A community forced inland over centuries might preserve stories of ancestral lands beneath the sea. Survivors of a tsunami might describe a day when the ocean crossed the shore and destroyed everything. Over generations, those accounts could merge with ritual, mythology, and symbolic teaching. Yet oral tradition alone cannot identify a specific archaeological event. Stories change. Different cultures experience different floods. Similar narratives can emerge independently because rivers overflow, storms create surges, and tsunamis strike many coastlines. Doggerland does not prove that every flood myth records the end of the Ice Age. It demonstrates something more precise and more important. Real inhabited landscapes were lost beneath rising seas. Human beings witnessed the transformation. Some settlements may still exist beneath North Sea sediment. The challenge is finding them. Marine sediment can both preserve and conceal evidence. In low-energy environments, mud may seal organic material away from oxygen. Wooden structures, plant remains, and bone can survive under favorable conditions. In exposed areas, currents may scatter artifacts and erode entire sites. Researchers must identify ancient riverbanks, protected lagoons, elevated ground, and zones where sediment accumulated quickly. These are the places most likely to contain preserved traces of human occupation. Future expeditions may find hearths, tools, fish traps, wooden platforms, dwellings, or burial sites. Such discoveries would not reveal an advanced technological empire. They would reveal the lives of real communities that adapted to a changing world. The importance of Doggerland lies in its confirmed existence. It is not a legend created by Plato. It is not a geometric pattern seen only on a sonar screen. It is a reconstructed landscape supported by geology, seismic data, environmental evidence, and archaeological finds. If such a large inhabited region could disappear beneath the North Sea, then other drowned landscapes may preserve equally important chapters of human history. One of the largest lies beneath the tropical seas of Southeast Asia. Its modern islands were once the highlands of a vast continental world. That world is called Sundaland. Today, Sumatra, Java, Borneo, and Bali appear as separate islands divided by the Java Sea, the Strait of Malacca, and parts of the South China Sea. During periods of lower sea level, these islands were connected to mainland Southeast Asia by exposed continental shelves. Together, these connected lands formed Sundaland. At the last glacial maximum, the coastline extended far beyond its modern position. The Java Sea became a broad lowland. The Strait of Malacca narrowed or disappeared across large sections. River systems crossed regions now covered by shallow tropical seas. Sumatra, Java, Borneo, and Bali stood as mountainous and elevated zones within a much larger landmass. Paleogeographic maps reveal enormous plains between them. Tropical rivers drained toward distant coastlines. Deltas expanded across low terrain. Lakes and wetlands occupied interior basins. Forests covered highlands and river valleys, although vegetation changed as climate conditions shifted. This landscape was large enough to function like a major continental region. Homo sapiens had already entered Southeast Asia long before the end of the Ice Age. Human populations moved through forests, river corridors, coastal zones, and island chains. They adapted to tropical environments, hunted animals, gathered plants, collected shellfish, fished, and built watercraft. The migration into Sahul, the combined Ice Age landmass of Australia and Papua New Guinea, demonstrates that prehistoric people crossed open water tens of thousands of years ago. Even when sea levels were lower, deep channels separated parts of Southeast Asia from Sahul. Reaching Australia required planned maritime movement. Adult groups navigated between islands. They carried tools, food, fire-making knowledge, and cultural traditions. They understood currents, coastlines, weather, and seasonal resources. Sundaland was not simply crossed. It was occupied for thousands of years. Communities lived near tropical rivers and coastal lagoons. Adults fished from simple watercraft. Hunters moved through forest edges. Groups gathered shellfish from tidal flats. Camps were established on elevated ground close to freshwater. Many of the most attractive settlement zones now lie beneath the Java Sea, the Strait of Malacca, and the South China Sea. As global climate warmed, the ocean slowly advanced across the lowlands. The process occurred over thousands of years. River mouths moved inland. Coastal plains narrowed. Freshwater valleys became estuaries. Forests were fragmented by rising water. High ground became islands. Communities adapted by moving toward new shorelines or migrating into interior regions. Some may have followed rivers northward. Others moved toward the highlands of Borneo, Sumatra, Java, and mainland Southeast Asia. Maritime groups could have traveled through expanding island networks. Each generation inherited a smaller landscape. A village once located far from the sea might eventually stand beside a tidal lagoon. A hunting ground could become a marsh. A river crossing might widen into a channel requiring boats. Burial places and ceremonial sites could be abandoned as waves approached. The human impact of these changes is difficult to measure because the central evidence is underwater. Genetic studies reveal population movement and interaction across Southeast Asia and the Pacific. Language distributions also preserve evidence of later migrations. Archaeological sites on surviving islands document long human occupation. Interpreting these patterns remains complex. Stephen Oppenheimer proposed one of the most influential and controversial explanations in his book Eden in the East. He argued that flooding in Sundaland displaced populations and contributed to cultural dispersal across parts of Asia and the Pacific. In this interpretation, Sundaland was not merely a passageway. It functioned as an important cultural hearth. As the sea rose, displaced groups carried knowledge, beliefs, technologies, and traditions into surrounding regions. Some genetic evidence is consistent with ancient population movement from Southeast Asia. Rising seas undoubtedly displaced people from low-lying areas. Human groups did migrate across the region. The controversy begins when these facts are expanded into claims about a highly organized civilization that influenced distant cultures. Genetic movement does not automatically prove urban centers, monumental architecture, writing, centralized government, or advanced technology. Populations can spread languages, tools, crops, rituals, and artistic traditions without belonging to a single civilization. Sundaland existed. It was inhabited. Its lowlands were flooded. People moved as the geography changed. These statements are supported by geological, archaeological, and genetic evidence. The claim that Sundaland contained a lost urban civilization comparable to later historical states remains unproven. No confirmed drowned city covering the region has been excavated. No secure archive of writing has been recovered. No monumental urban complex has been documented beneath the Java Sea. The absence of evidence does not prove that complex settlements never existed, but it prevents certainty. The potential archaeological area is immense. Surveying tropical seabeds presents major difficulties. Sediment from large rivers can bury sites under many meters of mud. Coral growth can cover exposed surfaces. Fishing, dredging, construction, and currents can damage archaeological remains. Visibility may be poor. Even identifying ancient river channels requires extensive geophysical data. Bathymetric maps can reveal large landforms, but smaller settlements may be invisible. Seismic survey data may show buried valleys, yet distinguishing a human occupation layer from natural sediment requires sampling. Sediment cores can identify charcoal, plant remains, or changes associated with human activity, but only across a narrow column. A single confirmed campsite could provide valuable information about migration and adaptation. A preserved coastal village could transform understanding of prehistoric life in Southeast Asia. The flooding of Sundaland also raises questions about memory. Across Southeast Asia and the Pacific, many traditions describe ancestral lands, overwhelming waters, migrating survivors, islands disappearing, or communities escaping to high ground. These stories cannot all be assigned to one event. Some may reflect river floods. Others may record tsunamis, storms, volcanic disasters, or symbolic narratives. Yet coastal change was a real and persistent experience. For thousands of years, people watched shorelines move. Communities were displaced. Familiar land disappeared beneath the sea. It is reasonable to ask whether some traditions preserve distant memories of these transformations. Memory does not remain unchanged across 10,000 years. Stories are adapted to new languages, religious systems, political needs, and local environments. A historical event may become a moral lesson. A regional tsunami may become a cosmic flood. A migration story may become an account of creation. The distinction between geological evidence and cultural memory must therefore remain clear. Geology can identify when coastlines changed. Archaeology can identify where people lived. Genetics can reveal relationships between populations. Mythology can show how cultures understood destruction, survival, and renewal. None of these forms of evidence should be treated as interchangeable. Still, Sundaland offers a powerful example of a drowned human world. Its rivers, forests, wetlands, and plains were real. Human populations occupied the region before the sea reached its modern level. Their movements contributed to the complex population history of Southeast Asia. What they built on the lost lowlands remains unknown. Perhaps most settlements were small camps and villages. Perhaps larger communities developed near major rivers. Perhaps social networks connected distant regions through maritime travel. Only systematic underwater archaeology can answer these questions. As Sundaland disappeared, new cultural centers emerged elsewhere. Some appeared at a time when traditional models once expected only small, mobile hunter-gatherer communities. One of the most extraordinary stood on a limestone hill in southeastern Turkey. Its massive pillars were raised approximately 11,600 years ago. The site became known as Göbekli Tepe. For much of modern archaeological history, the development of civilization was described as a relatively simple sequence. Human groups lived as mobile hunter-gatherers. The climate stabilized after the Ice Age. People domesticated plants and animals. Agriculture created food surpluses. Permanent villages expanded. Social hierarchies developed. Only then did communities build large ceremonial centers and monumental architecture. Göbekli Tepe complicated that sequence. The site stands in southeastern Turkey, on a limestone ridge overlooking the surrounding landscape. Its monumental enclosures date to the transition between the final Ice Age and the early Holocene. Some of its major structures were created approximately 11,600 years ago. When Klaus Schmidt began leading major excavations at Göbekli Tepe in the 1990s, archaeologists uncovered circular and oval enclosures containing massive T-shaped limestone pillars. Several pillars stood more than 5 meters high. Some weighed many tons. The stone surfaces carried reliefs of animals. Foxes, snakes, wild boar, birds, scorpions, and other creatures appeared in carefully carved forms. Abstract symbols covered additional surfaces. Some pillars displayed arms, hands, belts, and clothing details, suggesting that the T-shaped stones may have represented stylized human figures. The enclosures required planning. Workers had to identify suitable limestone. They had to quarry the stone using available tools. The pillars were shaped, transported, raised, and positioned within carefully organized spaces. This work required cooperation among many adults. A historical reconstruction shows groups using ropes, wooden supports, levers, stone tools, and coordinated labor. The process would have demanded knowledge of weight, balance, terrain, and material strength. Food and water had to be supplied. Tasks had to be assigned. Skilled carving required experience. Göbekli Tepe therefore demonstrates complex social organization among communities living near the end of the Pleistocene. It does not fit the older stereotype of Ice Age hunter-gatherers as culturally simple or incapable of large cooperative projects. The builders possessed symbolic traditions, social networks, technical knowledge, and the ability to organize labor on a substantial scale. This does not necessarily mean they lived in cities. The archaeological record around Göbekli Tepe includes evidence of settlement, food processing, and daily activity, but researchers continue to debate how permanently the site was occupied and how its functions changed over time. Early interpretations emphasized a ceremonial center used by mobile groups. Later discoveries complicated the boundary between ritual space and settlement. The site may have combined social, domestic, economic, and symbolic activities. The relationship between Göbekli Tepe and agriculture is also complex. The region contained wild ancestors of important domesticated plants. Communities were experimenting with resource management during this period. Plant cultivation and animal domestication developed gradually rather than appearing in a single moment. Göbekli Tepe shows that monumental construction and organized ritual activity could emerge before fully developed agricultural economies dominated the region. This changed the debate about the beginning of civilization. Some researchers suggested that communal ritual may have encouraged groups to gather, cooperate, and eventually settle more permanently. Others emphasized environmental change, resource concentration, population growth, and technological development. No single explanation is sufficient. The site also contains another mystery. Several enclosures were deliberately filled with stone, soil, animal bone, tools, and other material. The pillars were not simply abandoned in open air. Large volumes of debris were placed around them. Why this occurred remains uncertain. The filling may have been connected to ritual closure. Communities may have retired old structures before building new ones. The enclosures may have become unstable or unsuitable for continued use. The material could reflect repeated renovation, cleaning, construction, and disposal rather than one organized burial event. It would be inaccurate to claim that the builders intentionally hid Göbekli Tepe from future civilizations. The evidence shows deliberate filling, but the motivation remains debated. Alternative writers have linked Göbekli Tepe to a lost civilization destroyed by climate change or rising seas. In this interpretation, survivors from drowned coastal regions carried astronomical knowledge, religious traditions, and construction techniques into southeastern Turkey. Some versions describe Göbekli Tepe as a memorial to a vanished world. This idea is not supported by conclusive archaeological evidence. No inscription identifies the builders as refugees from Doggerland, Sundaland, Atlantis, or any submerged civilization. No confirmed maritime artifacts connect the site to a distant coastal culture. No technological remains demonstrate the survival of an advanced global society. Yet the question behind the hypothesis is legitimate. Where did the people who built Göbekli Tepe live before the site was constructed? Human communities did not suddenly appear on the hill without history. Their knowledge developed through earlier generations. Their symbolic systems had origins. Their social networks extended across landscapes that included rivers, valleys, plains, and possibly coastal zones. Some of those landscapes are now submerged. The Mediterranean coast, the Black Sea region, the Persian Gulf basin, and other continental shelves contained larger areas of dry land during the Ice Age. Populations living there may have moved as environments changed. Climate transition affected the entire region. Temperatures rose. Vegetation shifted. Water sources changed. Animal populations moved. Sea levels increased. Some groups adapted locally. Others migrated. It is plausible that displaced populations contributed knowledge and traditions to communities in inland regions. Human history is filled with cultural exchange produced by migration. What remains unproven is the claim that these migrants belong to a single advanced civilization. Göbekli Tepe does not need a lost empire to be extraordinary. Its builders were prehistoric human beings capable of planning, cooperation, art, symbolism, engineering, and ritual. Their achievements emerged from long cultural development among hunter-gatherer and early sedentary communities. The site reveals how much older complex social behavior may be than once assumed. It also reveals the danger of using the word civilization without definition. A community can organize hundreds of workers without possessing writing. A society can create monumental art without building a city. A population can maintain long-distance exchange without forming an empire. Complexity exists in many forms. Underwater archaeology may eventually identify coastal settlements connected to the broader cultural world that produced Göbekli Tepe. Such discoveries could reveal fishing technologies, trade routes, ritual practices, or migration patterns. They might demonstrate that large and stable communities existed near now-submerged rivers and shores. They would not automatically prove a technologically advanced global civilization. The strongest approach is to investigate without assuming the answer. Göbekli Tepe expands the range of what prehistoric communities could achieve. It pushes organized monumental activity deeper into the past. It suggests that important stages of social development occurred before the first recognized cities of Mesopotamia. The question is not whether conventional archaeology has ignored the site. Archaeologists excavated it, dated it, documented it, and revised existing models because of it. The deeper question is how many equally transformative sites remain undiscovered. Some may lie beneath modern settlements. Some may be buried under desert sediment. Others may rest beyond the coastline, beneath oceans that cover the most productive landscapes of the late Ice Age. The search for these sites leads to several disputed underwater formations. Near Japan, massive stone terraces descend beneath the sea. In western India, sonar surveys have been interpreted as evidence of an ancient settlement. In Egypt, a real historical city has been excavated beneath Mediterranean waters. Together, Yonaguni, the Gulf of Kumbat, and Heraklion demonstrate the full range of underwater interpretation, natural geology, disputed evidence, and confirmed archaeology. In 1986, a diver exploring waters near Yonaguni Island in Japan encountered a massive underwater formation. Broad stone surfaces extended across the seabed. Terraces descended like giant steps. Vertical walls met horizontal platforms. Long edges appeared unusually straight. The formation became known as the Yonaguni Monument. Located in an area of strong currents, the structure rises from the surrounding seabed as a large mass of sandstone and mudstone. Divers moving around it encounter flat surfaces, narrow passages, angular corners, and stepped levels. To some observers, Yonaguni resembles a ceremonial complex, fortress, quarry, or monumental platform constructed by an unknown prehistoric culture. Masaaki Kimura, a marine geologist who studied the site extensively, argued that parts of the formation may have been modified by human beings. He identified features interpreted as roads, terraces, drainage channels, steps, and possible carved forms. Supporters of human modification point to the apparent geometry. They argue that repeated flat surfaces and sharp angles are unlikely to be entirely natural. Some suggest that people shaped an existing rock formation rather than constructing the entire monument from separate blocks. In that scenario, the site could represent a natural geological mass altered through cutting, clearing, or quarrying. Other geologists disagree. The local sandstone contains horizontal bedding planes and vertical joints. These natural fractures create rectangular blocks, flat surfaces, and straight edges. Earthquakes, wave action, currents, and erosion can remove weakened sections of rock, producing terraces and steps. Similar formations appear on land in the region. A geologist examining the surface may observe fractures extending through the rock in consistent directions. When intersecting joints break away, the remaining mass can resemble architecture. The central debate is therefore not simply natural or artificial. A formation can be natural while containing limited human modification. People may have used the site, cut small features, or treated it as a ceremonial place without constructing the entire structure. No secure archaeological excavation has produced decisive evidence of a large built complex. No confirmed occupation layer, extensive tool assemblage, inscription, or architectural foundation has established the monument as a city. The age is also uncertain because stone cannot be dated simply by its appearance. Researchers must determine when the surface was exposed, when it became submerged, and whether any features were modified by people. Sea level history suggests that parts of the surrounding region were exposed during lower sea levels, but local geological history must also be considered. Yonaguni remains disputed. It is neither a confirmed lost city nor a meaningless illusion. It is a real geological formation whose degree of human modification has not been established conclusively. A second controversy emerged in the Gulf of Kumbat, on the western coast of India. In 2001, surveys associated with India's National Institute of Ocean Technology used sonar mapping to investigate pollution and seabed conditions. Researchers detected patterns that some interpreted as geometric structures beneath turbid water. Reports described possible foundations, rectangular forms, and organized features spread across the seabed. The claim attracted international attention when dredged materials were recovered from the area. These included pieces of wood, stone objects, fragments interpreted by some as artifacts, and other material brought up from the seabed. A piece of wood reportedly produced an ancient carbon date. This result was used to support claims that the Gulf of Kumbat contained a city thousands of years older than the earliest known urban centers. The problem was archaeological context. The objects were collected through dredging. A dredge removes material from the seabed and mixes objects from different layers and locations. Currents may transport wood, stone, shell, and sediment across wide areas. Rivers may carry old material into marine environments. An isolated piece of ancient wood does not date a sonar formation. The wood may have originated from a buried forest, an older sediment layer, river transport, or another location. Without controlled excavation, researchers cannot demonstrate that the object was part of a human-built structure. Carbon dating determines when organic material stopped exchanging carbon with the environment. It does not establish where the object was originally used or whether it belonged to a city. The sonar images also require caution. Strong currents, sediment ridges, erosion patterns, and geological structures can produce regular forms. Low-resolution sonar may transform natural features into shapes that appear architectural. To confirm an ancient settlement, archaeologists would need to document structures in place. They would identify walls, floors, post holes, hearths, roads, tools, food remains, and occupation layers. Each object would need a precise location within a stratigraphic sequence. That level of evidence has not been produced for the Gulf of Cuba claims. The site remains controversial. The possibility of prehistoric occupation along the ancient coastline is reasonable. Western India contained major rivers, productive coastal environments, and long histories of human settlement. The claim that sonar has revealed a 9,500-year-old city remains unconfirmed. A very different underwater discovery occurred near Alexandria, Egypt. For centuries, historical sources described the city of Heracleion, also known as Thonis Heracleion. It was an important port near the Nile Delta. Ships entered through its waterways. Temples stood beside channels. Merchants exchanged goods. Religious ceremonies connected the city to the wider Mediterranean world. Over time, Heracleion disappeared beneath the sea. Modern underwater archaeology located its remains in Abu Qir Bay. Unlike disputed sonar formations, Heracleion produced unmistakable evidence of urban occupation. Underwater archaeologists found temple foundations, monumental statues, columns, inscriptions, anchors, coins, ceramics, jewelry, ritual objects, and the remains of ships. The artifacts remain connected to identifiable structures and historical contexts. Large statues rested in sediment. Stone blocks marked temple areas. Coins and pottery documented trade and daily life. Inscriptions helped identify the city. Heracleion was real. It was not an Ice Age civilization. It flourished in historical times, thousands of years after the last glacial maximum. Its discovery does not prove Atlantis or a global lost culture. It does prove that entire cities can sink and remain hidden beneath water. The Nile Delta is geologically unstable. Thick layers of water-saturated sediment accumulate where the river meets the Mediterranean. Heavy buildings place pressure on this unstable ground. Subsidence can gradually lower the land. Earthquakes may destabilize sediment. Liquefaction can occur when water-saturated ground loses strength during shaking. Structures sink, tilt, or collapse. Rising sea level and coastal erosion increase the damage. Heracleion appears to have been affected by a combination of these processes. Parts of the city sank. Water covered streets and temples. Sediment buried structures. The same environment that destroyed the city also preserved many objects beneath the seabed. Heracleion provides a standard of evidence. A confirmed submerged city contains architecture, artifacts, inscriptions, datable layers, and clear signs of human activity. Yonaguni contains a geological formation with disputed modification. The Gulf of Cuba contains sonar interpretations and dredged materials without secure archaeological context. The Cuban site contains unusual deep water forms but no conclusive excavation. These locations should not be presented as equal. Underwater archaeology depends on evidence, context, and repeatable investigation. A shape resembling a wall is only the beginning. Researchers must determine its material, origin, age, and relationship to surrounding deposits. The ocean contains natural terraces, volcanic columns, fractured sandstone, shipwrecks, drowned villages, ancient ports, and entire cities. Some formations will prove geological. Some may show limited human use. Others may reveal settlements lost to subsidence, earthquakes, tsunamis, or sea level rise. The challenge is distinguishing one from another. That challenge becomes even more difficult when archaeological evidence is combined with mythology. Stories of destructive water appear across many cultures. Historical records describe migrations, collapsing kingdoms, and fleets arriving from unknown regions. Plato described a powerful island destroyed by the sea. These accounts have been linked to flood myths, the Sea Peoples, and Atlantis. But the connections are far more uncertain than the stories suggest. Stories of great floods appear in cultures separated by oceans, deserts, and thousands of years. Some describe rivers rising beyond their banks. Others describe the sea crossing the land. Some tell of survivors escaping in boats. Others describe families reaching mountains, islands disappearing, or entire communities being destroyed. The similarity of these stories has often been presented as evidence of one global catastrophe. The geological record does not support a recent flood covering the entire planet and every mountain at the same time. It does support countless regional disasters. Rivers overflow. Monsoon systems fail or intensify. Tropical cyclones create storm surges. Earthquakes generate tsunamis. Volcanic eruptions collapse islands. Landslides displace water. Sea level rises across generations. Different cultures may therefore develop flood stories independently because water disasters are common features of human experience. Some traditions may preserve memories of specific events. Indigenous oral histories in several regions have been compared with geological evidence of coastal change, volcanic eruptions, and tsunamis. In certain cases, geographic details appear to correspond with landscapes transformed long before written records. Such examples show that oral tradition can preserve information across long periods. They do not prove that every flood myth records the same event. Memory is shaped by repetition, ritual, language, and social meaning. Historical details may survive beside symbolic elements. A local flood can become a story about divine judgment. A tsunami can become a cosmic battle. A migration can become the founding story of a people. Flood myths must therefore be studied as cultural evidence, not treated as direct geological measurements. The same caution applies to historical accounts of migration and collapse. Around the end of the Late Bronze Age, major societies across the eastern Mediterranean experienced severe disruption. Cities were destroyed or abandoned. Trade networks weakened. Political systems collapsed. The Hittite Empire disappeared. Several Mycenaean centers declined. Egypt survived but faced major military and economic pressure. This period is known as the Bronze Age collapse. Egyptian inscriptions and reliefs describe conflicts involving groups later called the Sea Peoples. The records show ships, warriors, families, prisoners, and battles. They identify several group names, but their origins remain debated. Older interpretations often described the Sea Peoples as foreign invaders who suddenly attacked established civilizations. Modern research presents a more complicated picture. Some groups may have been raiders. Others may have been mercenaries. Some could have been displaced populations searching for land. Coalitions may have included people from different regions. The movements occurred during a period of environmental and political stress. Paleoclimate evidence indicates severe drought in parts of the eastern Mediterranean. Crop failures could have created famine. Trade disruptions would have reduced access to grain, metals, and other resources. Earthquakes damaged cities. Political conflict weakened central authority. When several crises occur together, populations move. Farmers abandon dry land. Hungry communities enter neighboring territories. Mercenaries change allegiance. Refugees travel by land and sea. Local conflicts become regional wars. The Sea Peoples may therefore represent a mixture of invasion, migration, piracy, military service, and displacement. Their identity has not been conclusively established. Some lost civilization theories connect the Sea Peoples to Atlantis. In these interpretations, survivors of a drowned island migrated into the Mediterranean and attacked established kingdoms. No archaeological evidence confirms this connection. The primary source for Atlantis is Plato. In the dialogues Timaeus and Critias, Plato described a powerful island civilization located beyond the Pillars of Hercules, usually associated with the Strait of Gibraltar. Atlantis possessed a large military force and attempted to dominate parts of the Mediterranean world. According to the story, ancient Athens resisted the invasion. Atlantis was later destroyed by earthquakes and floods, disappearing beneath the sea. Plato placed the events approximately 9,000 years before the time of Solon, the Athenian statesman through whom the story was supposedly transmitted. This chronology has attracted attention because it falls near the broad period when the last ice age was ending and sea levels were rising. The resemblance is intriguing. It is not proof. Plato did not provide a geological survey. His date may have served a literary or symbolic purpose. Ancient numbers were vulnerable to copying errors, translation differences, and interpretation. The story appears within philosophical dialogues concerned with ideal societies, political power, morality, and decline. The predominant academic interpretation considers Atlantis a philosophical narrative created by Plato. In this view, the island is not a literal historical place. It functions as a political and moral contrast. Atlantis represents wealth, imperial ambition, and corruption. Its destruction demonstrates the consequences of excess. Other researchers have explored possible historical inspirations. The Minoan civilization on Crete and nearby islands experienced the effects of the Thera eruption during the 2nd millennium BCE. The volcanic explosion devastated the island of Thera, generated tsunamis, damaged coastal settlements, and affected regional trade. The Minoans were a maritime culture with impressive architecture and extensive Mediterranean connections. However, the geography, chronology, and details do not match Plato's account exactly. Thera lies inside the Mediterranean, not beyond the Pillars of Hercules. The eruption occurred thousands of years later than Plato's stated date. The comparison may show how memories of real disasters influence stories. It does not identify Minoan Crete as Atlantis with certainty. Other proposed locations include regions near Spain, the Atlantic Islands, North Africa, the Black Sea, the Caribbean, Antarctica, and submerged areas around the world. None has been archaeologically proven to be Plato's Atlantis. The Cuban formations have been associated with Atlantis because of their geometric appearance and location in the western Atlantic. Yet no evidence connects them to Plato's text. Their depth creates major geological problems. No datable city has been excavated. Yonaguni has also been called Atlantis despite being located on the opposite side of the world. This reveals how the name has changed. Atlantis is often used not as a precise archaeological hypothesis but as a symbol for any mysterious submerged formation. A more productive interpretation considers Atlantis as a cultural image of drowned landscapes. Human beings lived through thousands of years of sea level rise. Doggerland disappeared. Sundaland fragmented. Coastal plains around the Mediterranean, Persian Gulf, Caribbean, and other regions were flooded. Tsunamis destroyed settlements. Subsidence swallowed cities such as Heracleon. Memories of these events may have influenced later stories. Plato could have drawn from traditions about earthquakes, maritime powers, coastal destruction, or ancient floods. He may have combined several historical motifs into a philosophical narrative. This possibility remains speculative. There is no continuous chain of evidence linking a specific Ice Age settlement to Timaeus and Critias. Yet Atlantis may endure because the central image is real. Land can disappear beneath the sea. Cities can sink. Populations can be displaced. Memories can survive long after the original landscape has vanished. The most cautious conclusion is that Atlantis has not been identified as a historical civilization. The story may be philosophical, historically inspired, or shaped by older traditions of catastrophe. Its value lies not in proving one lost empire, but in directing attention toward the many real landscapes that were submerged. Perhaps Atlantis is not the memory of a single city. Perhaps it represents the human fear of losing the coast, the home, the harbor, and the familiar world to water. Perhaps different cultures preserve different versions of the same broad experience without sharing one original event. To move beyond mythology, researchers need evidence from the seabed. They need high-resolution maps, sediment cores, underwater excavation, datable artifacts, and geological context. Modern technology is finally making that possible. The continental shelves surrounding the modern continents form one of the largest unexplored archaeological regions on Earth. During the last glacial maximum, many of these shelves were dry land. Rivers crossed them. Lakes occupied depressions. Wetlands formed around estuaries. Animals migrated across open plains. Human communities used shorelines that now lie tens or hundreds of meters underwater. Finding those landscapes requires specialized technology. Sonar mapping allows research vessels to scan wide areas of the seabed. Multi-beam sonar sends multiple sound signals toward the bottom and measures their return. The resulting data create detailed three-dimensional maps of underwater terrain. Bathymetric mapping reveals ridges, valleys, terraces, channels, and submerged coastlines. Sidescan sonar produces images based on the strength of reflected sound. Hard rock returns a different signal from soft sediment. Objects standing above the seabed create acoustic shadows. These systems can identify shipwrecks, rock formations, large structures, and changes in surface texture. They cannot independently prove human construction. Seismic survey data penetrate below the seabed. Sound waves reveal buried sediment layers, ancient river channels, lake basins, and geological boundaries. A river valley hidden under 20 meters of marine sediment may be invisible on the modern seafloor. Seismic imaging can reveal its shape. Researchers then use paleogeographic reconstruction to estimate how the region appeared at different times. Models associated with scientists such as Glenn Milne combine sea level history, ice sheet change, glacial isostatic adjustment, tectonic movement, and modern elevation data. These models help identify ancient shorelines and areas that may have offered favorable conditions for settlement. The maps are not perfect. Local subsidence, erosion, sediment accumulation, and tectonic deformation create uncertainty. A coastline reconstructed for 10,000 years ago may shift when new geological data become available. Even so, these models provide a scientific starting point. Researchers can target ancient river mouths, protected bays, freshwater lakes, elevated ridges, and zones near former coastlines. Autonomous underwater vehicles can survey these areas without remaining connected to a ship. They follow programmed routes close to the seabed, collecting sonar data, photographs, chemical measurements, and depth information. Remotely operated vehicles remain connected to a vessel by cable. Pilots control them from the surface. Robotic arms can collect samples. Cameras record formations in deep water. Divers can investigate shallow sites directly, but depth and time limits restrict their work. Strong currents, low visibility, cold water, and decompression requirements increase risk. Sediment cores provide another source of evidence. A hollow tube is pushed into the seabed and removed with layers of sediment inside. Each layer represents a period of environmental history. Pollen can identify nearby vegetation. Shells and microorganisms reveal water conditions. Charcoal may suggest fire. Plant remains can be dated. Changes in grain size may record storms or tsunamis. Possible evidence of human activity may include microscopic charcoal, disturbed sediment, concentrated organic material, or chemical signatures. These indicators are not sufficient alone. They guide further investigation. Controlled underwater excavation remains essential. Archaeologists establish a grid around the site. Sediment is removed carefully. Every object is recorded in position. Photogrammetry creates detailed three-dimensional models. Samples are labeled and protected from contamination. The relationship between objects matters as much as the objects themselves. A stone tool found alone demonstrates human presence. Several tools around a hearth suggest an activity area. Post holes and floor surfaces may indicate a dwelling. Storage pits, roads, workshops, defensive walls, public buildings, and dense settlement patterns may indicate an urban community. The word civilization should not be applied before the evidence supports it. Confirmed submerged prehistoric sites have already been found in several regions. Stone tools, wooden structures, fish traps, settlements, and human remains demonstrate that coastal communities occupied landscapes later covered by the sea. These discoveries prove that underwater archaeology can recover early human history. They do not prove a forgotten global empire. The scale of the search remains overwhelming. Millions of square kilometers of continental shelf were exposed during periods of lower sea level. Mapping every ancient river and coastline would require decades of coordinated research. Excavating even a small site can require years. Funding is limited. Research vessels are expensive. Underwater vehicles require maintenance. Storms interrupt operations. Saltwater damages equipment. Sediment may bury sites deeply. Organic preservation varies. Political borders divide ancient landscapes. Modern infrastructure, fishing, mining, dredging, and coastal construction threaten archaeological remains before they are identified. The seafloor is often compared with the surfaces of the Moon and Mars. Spacecraft have produced detailed global maps of other worlds, while large regions of Earth's ocean floor remain mapped only at relatively low resolution. The comparison is not exact, because deep water mapping requires ships to move physically across vast areas. Satellites cannot see through seawater with the same precision. Yet the contrast reveals the scale of what remains unknown. The mystery is not created by an organized academic conspiracy. It is created by cost, depth, pressure, distance, sediment, limited technology, and the enormous size of the ocean. Scientific institutions do not need to hide underwater discoveries to protect a historical narrative. Archaeology changes when evidence changes. Göbekli Tepe transformed models of prehistoric social organization because archaeologists excavated and documented it. Doggerland became an accepted field of study because geological and archaeological evidence accumulated. A confirmed Ice Age settlement beneath the sea would be studied, debated, and incorporated into human history. The Cuban formations remain unconfirmed because the necessary evidence has not been collected. The sonar patterns are real. Their interpretation is uncertain. At more than 600 meters of depth, any claim of former human occupation must explain not only sea level change but also regional geology, tectonic movement, and subsidence. Doggerland rests on stronger evidence. Its landscape has been reconstructed through seismic data. Animal bones, stone tools, and worked antler confirm human activity. The region disappeared gradually as the sea rose, while the Storega tsunami may have devastated surviving coastal areas. Sundaland also rests on strong geological evidence. Its exposed plains connected modern islands. Human populations occupied Southeast Asia and migrated through the region. Rising seas flooded the lowlands and displaced communities. What remains unknown is the scale and complexity of the settlements that existed there. Göbekli Tepe is a confirmed archaeological site. Its pillars demonstrate large-scale cooperation, symbolic traditions, and monumental construction approximately 11,600 years ago. It does not prove a lost global civilization, but it reveals that prehistoric societies were more organized and culturally complex than older models assumed. Yonaguni remains disputed. Its geometric appearance may result primarily from natural sandstone jointing and erosion. Limited human modification remains possible, but a constructed city has not been demonstrated. The Gulf of Kumbat claims remain uncertain because sonar interpretations and dredged objects lack secure archaeological context. Heraclean is confirmed. Its temples, statues, coins, ships, and inscriptions demonstrate that a historical city sank near the Nile Delta through processes including subsidence, sediment instability, and liquefaction. Flood myths remain cultural evidence. Some may preserve memories of local disasters. Others may be symbolic or independent. Similar stories do not automatically prove one global flood. The Sea Peoples remain historically documented but incompletely understood. Their movements occurred during a broad collapse shaped by warfare, drought, famine, earthquake, economic disruption, and political instability. Atlantis remains unproven. Plato's narrative may be philosophical. It may include echoes of real historical disasters. Its chronology loosely overlaps with the long transition out of the Ice Age, but that resemblance is not archaeological proof. When all of these subjects are placed together, a pattern emerges. The confirmed evidence is already extraordinary. Coastlines moved. Continental shelves flooded. Human populations were displaced. Habitats disappeared. Some cities sank. Some prehistoric landscapes survived beneath sediment. The unanswered question concerns scale. Were the lost coastal regions occupied mainly by small mobile groups? Did stable fishing villages develop beside ancient estuaries? Did major river deltas support large settlements before agriculture became widespread? Did maritime exchange networks connect distant communities earlier than currently documented? Could complex social centers have existed on coastlines that are now inaccessible? These questions do not require machines, extraterrestrial intervention, or a technologically advanced Ice Age empire. They require archaeology. A final map of Earth appears with modern oceans covering the continent's margins. Then ancient Ice Age shorelines are placed over the modern planet. The difference is immense. The North Sea becomes land. The Persian Gulf becomes a river basin. Sundaland joins Southeast Asia. Australia connects with Papua New Guinea. Caribbean islands expand across exposed shelves. The camera moves downward toward the oceans. Beneath the water, ancient river channels cross submerged valleys. Sediment covers former lakes. Stone tools rest where human hands left them. Broken coastlines remain hidden beneath coral, sand, and mud. The research vessel returns to the Caribbean Sea. The sonar screen again displays geometric forms near western Cuba. A remotely operated vehicle moves through the darkness. Its lights reveal stone surfaces emerging from sediment. Some edges appear regular. Other features resemble fractured natural rock. No inscription identifies the site. No excavation confirms a city. No geological explanation has been tested through a complete multidisciplinary investigation. The formations remain exactly what the evidence allows them to be, an unresolved feature of the deep seabed. Above them, the ocean appears empty. But the ocean is not empty. It covers roads once traveled by animals and people. It covers forests that grew beyond modern coastlines. It covers riverbanks where adults shaped stone tools, prepared food, repaired fishing equipment, and watched the climate change. It covers settlements that may have been occupied for generations. Some were probably small. Some may have been complex. Most remain undiscovered. The possibility that important prehistoric sites exist beneath the oceans is not a fringe idea. It is a direct consequence of documented sea level rise since the last glacial maximum. The controversial question is not whether human landscapes were submerged. They were. The question is what those landscapes contained. Future sonar surveys may reveal ancient river systems. Sediment cores may identify human activity. Underwater excavations may uncover houses, tools, burials, fish traps, ceremonial structures, or settlements older than expected. Some discoveries will confirm existing models. Others may force archaeology to revise the timeline of social organization, maritime travel, trade, and permanent settlement. No responsible investigation can promise a lost civilization. But no responsible history can ignore the drowned world. The oldest chapters of human life were written before modern coastlines existed. Part of that record remains on land. Part was destroyed by erosion. And part may still survive in darkness beneath the ocean. If archaeologists one day uncover a complex settlement built before the end of the last ice age, the discovery would not erase human history. It would expand it. It would show that the path towards civilization was older, more varied, and more deeply connected to the world's vanished coastlines than previously understood. Until that evidence is found, the mystery remains open. How many settlements lie beneath the continental shelves? How many migration routes disappeared under rising water? How many traditions began as memories of real coastlines? And how much of the story of civilization is still buried beneath the oceans?